Hello students, welcome to 6th lecture of electrochemistry. In previous lecture we discussed about Nernst equation, which is used to find the cell potential when we have non-standard condition. That means concentration more or less than 1, which is not equal to 1. So we observe that it is actually relationship between the equilibrium constant and electrochemistry. We observe that in Nernst equation we have E as well as K. That means we can say that it is a one type of unit of electrochemistry, whereas K is the unit of chemical equilibrium. So it represents both of them, or both of this branch of chemistry are related with each other. Now in today's topic we will start with a relationship between thermodynamics and electrochemistry. So today's point is electrochemical cell and Gibbs energy of the reaction. Electrical work done in 1 second is equal to electrical potential of multiplied by total charge passed. If you want to obtain maximum work from galvanic cell, then charge has to be passed reversibly. The reversible work done by the galvanic cell is equal to decrease in the Gibbs energy, and therefore if EMF of the cell is E and NF is the amount of charge passed. So as mentioned, we have to multiply it, and delta G is the Gibbs energy of the reaction. Then our equation will be delta G is equal to minus NFE. This is the relationship between thermodynamics and electrochemistry, because delta G is the unit of thermodynamics and E is the unit of electrochemistry. So notice here, value of delta G is positive, at the same time value of E is negative. N is the number of electron transferred during the reaction, F is Faraday, which is constant. So they do not have negative signs. Number of electron transferred during the reaction will be positive always. And the Faraday is a value of charge of 1 mole of electron. So they are constant values, and negative value denotes E is equal to negative. So if delta G is positive, it represents non-spontaneous reaction, and at the same time value of E will be negative for non-spontaneous reaction. If delta G is negative, then it represents spontaneous reaction, and at the same time value of E will be positive, which represents spontaneous reaction. So in short, positive value of E and negative value of delta G represents spontaneous reaction, and positive value of delta G and negative value of E represents non-spontaneous reaction. Now one reaction is mentioned here. So as we can see, we have zinc and copper ions reaction, already known reaction, which gives zinc ions and copper metal. Now in this case, number of electron transferred during the reaction is equal to 2. So our equation will be delta G is equal to minus 2Fe. Now remember that E cell is intensive parameter, whereas delta G is extensive thermodynamic property. So in this case, delta G, it is extensive, so it do not depend on internal factors, whereas internal properties do affect with internal factor changes. So as we can see, in next equation we doubled the concentration of the reactants, and obviously you will get double amount of product. So 2 moles of zinc metal plus 2 moles of copper ion gives 2 moles of zinc ion and 2 moles of copper metal. So in this case, the value of delta G will remain delta G. You don't have to multiply it with 2, whereas on the right hand side equation it is multiplied by 2. Now instead of 2 we have 4. That means 4 electrons will transfer during the reaction. As we can see in this equation, if we have 2 moles of zinc metal, that means it will produce 2 moles of zinc ion. Now change of the charge per 1 zinc is equal to 2, and we have total 2 of them. So total 4 electron transfer will takes place. That's why we have to place 4. So it represents value of E is internal factor, whereas value of delta G is external. So if concentrations are in unity or they are 1, it represents cell potential will be standard cell potential. So if standard cell potential is there, then if we place it in this equation, you will get standard Gibbs free energy. And equation number 3.16 will be our main equation, which represents relationship between delta G and E, that means thermodynamics and equilibrium. So from this relationship we can find cell potential or Gibbs free energy, which is unknown to us. And if we find both of them, later we can find equilibrium constant, because delta G is equal to minus RT ln K. We already know this equation, which represents relationship between delta G and K, that means thermodynamics and equilibrium. So as we can see, all of these equations are related to each other. Now delta G is equal to minus NFE and delta G is equal to RT ln K. So we can say that minus NFE note is equal to minus RT ln K. So this equation represents relationship between delta E note and K, that means equilibrium and electrochemistry. Or we can rewrite this equation as follow, or even we can shift NF value on the right hand side, so you will get E is equal to RT upon NF into ln K. So maybe this equation might feel familiar, because this is the relationship we discussed earlier in Nernst equation. Okay, we can further expand this equation and you will get Nernst equation. So all of these three branches of chemistry are actually related to each other. Now one example is mentioned. Standard electrode potential of Daniell cell is 1.1 volt and the standard Gibbs energy for the reaction Zn solid plus copper plus 2 gives Zn plus 2 and copper solid. So as mentioned in question, we have standard electrodes, that means concentrations will be in unity. So we have to use equation which represents standard Gibbs free energy. So it will be delta G is equal to minus NF E naught. Now in this reaction, number of electron transferred during the reaction is 2. Observe the oxidation state of copper. Earlier it was plus 2 and after the reaction it is 0. So it represents 2 electrons are transferred. So value of N is equal to 2. F is constant and always its value will be 96,487 coulombs. It is the charge of 1 mole of electron. Find the charge of 1 electron and multiply it with 1 mole. You will get this value. Okay. So F is constant 96,487 and standard cell potential is already mentioned 1.1 volt. So putting these values in this equation, that means N is equal to 2 multiply by 1.1 volt multiply by 96,487, you will get minus 21,227 joules per mole or minus 212.27 kilojoules per mole, which represents during this reaction, if you have 1 molar concentration of copper plus 2 ions in this reaction, then it will release total 212 kilojoules of energy per mole. So this reaction is exothermic and releases energy, but during this process released energy will be in term of electricity. So you got the value of the amount of heat. If this reaction produces heat, then amount of heat will be 212, but this reaction actually produces electricity equals to 212 kilojoules of energy. Now few in-text questions are mentioned. So let us quickly discuss about the method, what you need to do to calculate these equations. So first question is calculate the potential of hydrogen electrode in contact with the solution whose pH is 10. So as mentioned here, hydrogen electrode has 0 potential. So value of hydrogen will be used as a 0. Other solution has pH is equal to 10. So that means it contains 10 pH and you have to find first of all concentration of H plus in which pH is equal to 10. We know that pH is equal to negative logarithm of H plus. So using this equation, pH value is already mentioned. You have to find the concentration of H plus. Put this value of concentration of H plus in Nernst equation and you will get your answer. But if you still find any confusion, feel free to ask. We will discuss these questions in detail, step by step, so you can get it. But first try to calculate it yourself. Second, calculate the EMF of cell in which the following reaction takes place: nickel solid plus 2 silver plus iron, concentration 0.002 molar, and it gives nickel plus 2 ions which has 0.16 molar concentration plus 2 Ag plus. So that means our main reactant will be silver plus and main product will be nickel plus 2 solution. Now number of electron transferred during the reaction is equal to 2. Standard cell potential is already mentioned. Now you have to find cell potential, non-standard cell potential. That means you have to use Nernst equation and place the value of concentration, but keep in mind number of moles of silver is 2. So you have to use concentration of silver raised to 2 because it has 2 molar concentration. Last example, the cell in which the following reaction occurs: 2 Fe plus 3 plus 2 I minus, which gives 2 Fe plus 2 plus I2. So standard cell potential is already mentioned, 0.236 at 298 Kelvin. Calculate the standard Gibbs energy and the equilibrium constant for the reaction. That means you have to use two equation. Delta G naught is equal to minus NF E naught and delta G naught is equal to minus RT ln K. Okay, so you have to use these two equation. First of all, number of electron transferred during the reaction. So concentrate on 1 Fe. Initial oxidation state was plus 3, after reaction it is plus 2. So 1 electron transfer per 1 Fe. We have 2. So number of electron transferred during the reaction is equal to 2. F is equal to 96,487. Standard cell potential is already mentioned, 0.236. So put this 3 value in this equation and find the value of delta G naught or standard Gibbs free energy. Put the value of standard Gibbs free energy in this second equation. We know the value of R, it is constant. We know the value of temperature, it is mentioned 298 Kelvin, and find the value of ln K or log K. And then later you have to take the anti-log to find the value of K. Now if you find difficulty in calculation, then feel free to ask. As I said, we will discuss it in detail, but first you have to calculate it yourself and you have to share your work or your calculation with me, then we will discuss about it in detail. From next lecture we will discuss about the conductance of electrolytic solution. So in this point we will discuss about different type of equations and different type of conductivities of electrolytic solution. So mainly we know only one type of conductivity when we place one electrode on the right hand side, second electrode on left hand side, and when we pass the electricity, you will notice electrical flow will be observed, which is normal conductivity. Then we will discuss about molar conductivity and some other calculations and phenomena and terms. So if you find any difficulty in last topic, feel free to ask, and then we will discuss about the next topic, conductance.